We have the final presentation of day one. And I'll pass you straight across to Grzegorz Tworek.
Thank you very much. As you already know, my name is Grzegorz, or Greg if you prefer. I used to dig deeper and deeper into Windows internals. This is what I do because I simply love it. I'm also doing this for work, and that someday I was asked about protecting quite huge environment with AppLocker. So I started to dig deeper, and this session is actually about things I have found when digging deeper into the AppLocker. Very briefly about the agenda. So what I want to tell you, what I want to show you, it is not only about the cache. However, this is the most important and I believe most interesting part of the session, but also about some other things, including some quick introduction about the AppLocker, about the idea, and so on. So, when it comes to AppLocker, is one of 3 Microsoft approaches to application whitelisting. Application whitelisting is a change the paradigm of protecting your PCs, because in most cases, when we want to protect our PCs from malicious applications, we are using kind of blacklisting, for example, antivirus or anti-malware software. So if the software knows some executable file is bad, or simply saying unwanted, it will not allow it to run. This is the blacklisting approach. But if someone compiles, modifies, changes, whatever does, and application is obviously malicious, but not recognized by your antivirus, it will be allowed to run because it's not recognized. Whitelisting changes the approach to the opposite one. So only allowed applications are allowed to run. Only known applications can run within the environment, making the management quite harder because we have to whitelist every single application we expect within the environment, and at the same time improving the protection greatly, because if some new application which we do not know appears within the environment, it will simply not run, so nothing malicious can be launched by malicious or just unaware user. As I said, Microsoft had 3 different approaches to the whitelisting topic. The first one appeared in the Windows XP. It was SRP, Software Restriction Policies. Software Restriction Policies was enforced by the Explorer process, and the Explorer process is owned by the user logging onto the workstation, so it effectively means a user has a full control over the process trying to control a user, making the solution not that successful. One of the best known solutions for disabling SRP, Software Restriction Policies, was an application called GPDisable. And the application GPDisable was written by Mark Russinovich and magically disappeared from the internet after Mike Russinovich joined Microsoft. In Windows Vista, it was slightly changed, because in Windows Vista, if you dig deeper to a newer version of Windows, you will see something under registry keys and so on, called SRP version 2. From the marketing perspective, from the official documentation perspective, SRP version 2 is AppLocker. AppLocker consists of a couple of components. I will cover them briefly in a moment. In the meantime, I will mention the third approach Microsoft made. It is WDAC, Windows Defender Application Control. Windows Defender Application Control relies on the deepest level of the protection, I would say, including hardware-based protection against malicious applications. Microsoft is trying to support in parallel AppLocker and WDAC. For some scenarios, AppLocker is better. For example, AppLocker is user-aware, which means I can allow some stuff to be run by a special group members and do not allow the same stuff to run if a user does not belong to this group. For WDAC, it is absolutely impossible. If something is not whitelisted, it will never run on this particular machine. There are some tables comparing side to side on Microsoft website those two solutions so you can easily compare them and find which one is better for you. In my opinion, WDAC is way harder to be managed. WDAC provides stricter protection. I would use WDAC for some devices not being actively changed over time, or at least not so often. For example, like ATM, kiosks, etc., some point of sale, sales, Windows devices, etc. When it comes to AppLocker, we have a couple of components within the solution to briefly end with the theory. So we have nice graphical user interface for the management. We have PowerShell commandlets. The thing being created within the AppLocker management is translated to a kind of a database, which is in turn translated by a special Windows service AppID SVC to the version being acceptable by the kernel driver, and the kernel driver is responsible for enforcing application whitelisting. So as it is kernel component, it cannot be easily manipulated by a user not having administrative permissions. Of course, if we have administrative permissions for any of those solutions, we can simply, if not bypass them, we can disable them because it is what is allowed for administrators. So it will not protect you from someone being already an administrator. Maybe it will protect from a stupid administrator doing things which shouldn't be done, but at the same time, if an admin wants to disable protection, it has such possibility for SRP, for AppID, AppLocker, and for WDAC. If you do not trust your admin, I'm always saying it means you should look at different operating system, not on the Windows one, because Windows itself cannot effectively defend from someone being already an admin. Okay, how we can whitelist application, how we can show, how we can tell to the solution something is allowed and something is not allowed. In AppLocker, I will demonstrate it in a moment. We have three ways of doing this. The first one is to specify a path to a file. So if something has a particular path, C program file something.exe, it means it is allowed. If the path is different, this rule does not match, and other rule must allow us to run this particular piece of software if we want it running. Another approach, path is quite simple, but at the same time, if someone can manipulate the drive, replacing the legitimate executable file with something malicious, this malicious piece of software will be allowed to run because path matches the rule. The second approach is based on hashes. So the hash of executable file is being calculated, and if hash matches, then application is allowed to run. If hash does not match, application is not allowed to run. This way is definitely the most secure one, because every single bit changed within the executable file will mean this application is not allowed to run anymore. But at the same time, a management will be a nightmare, because try to imagine what will happen after patches. After patching Tuesday, if half of your executable files changed, so their hashes changed as well, and you have to calculate new hashes and update your whitelisting solution to reflect those changes. The third one relies on digital signatures. Okay, let's go for some real thing. So I will launch the management. It is done through local security policies or through group policies. Here you can see the console. Within the console, I have predefined rules. I have AppLocker up and running here with the service running and so on, so it is ready to go. I'm using two default rules. By default, we have three rules, which is, again, it is not by default. But if we do not have rules, we can create default rules, and we'll have three rules. The third one is about allow everything for administrators. And those two left here is allow everything if it is within the program files, and allow everything if it is the Windows folder. It is not perfect, but at the same time is quite good because only administrators are able to drop a file into those folders in most cases. When it comes to rules, we can have rules for executable files, we can have rules for installer, not that practical, for script, not practical at all, and for packaged app rules, not practical because I never seen a malicious software distributed as packaged app. Within the AppLocker, if I go for properties, on the advanced, you can additionally enable DLLs to be monitored. With DLLs, there's one thing. The landscape of DLLs on every single PC is way more complex and less guarded than the landscape of .exe files. When it comes to the content, the type of the file, actually .exe and .dll is the same. It is portable executable format. The only difference is how we launch this particular type of file, because for .exe it is enough to double click on it, and for DLL there must be a process loading this DLL and automatically or intentionally call one of methods being exported from the DLL. Automatically, I mean the special export from the DLL. It is well documented. It is called DLL main. DLL main export is automatically launched, run, when DLL is loaded into any process. So if we create a malicious DLL having DLL main function inside, if any process loads this DLL, this malicious function will be executed and our code will execute, will run. So the only issue with DLLs is to host them somehow within another process. We have a couple of legitimate and a couple of unusual ways. To mention the legitimate way, we have run DLL32, one of those. We have rec svr32, another one, calling some methods from the DLL. When it comes to unofficial, one of my findings, I really like it. If there is a format utility, let's go for the format, and within the format parameters, one of those being presented by the format utility is file system being specified by /fs and the file system. And you can see we can specify /fs colon and then specify a file system. It is FAT, FAT32, and TFS, and so on and so on. And is it format that's smart? It knows every single file system format? Not at all. There are DLLs on the drive. Dear C Windows System 32U DLL, you can see over here a couple of DLLs like UFAT, UXFAT, UNTFS, UNTFS is happening here, and so on and so on. What does the format utility do? If you specify a file system, it will load the DLL name U plus the file system you specified, and it does not check if such file system make any sense or not. If you specify format /fs colon U test, which is not file system at all, format utility will load utest.dll and execute the DLL main. So please protect yourself from launching DLLs as well, even it is way more complex when it comes to AppLocker and other solution. For AppLocker, we have to check this checkbox and new entry appears within the graphical interface. What AppLocker can do? Actually, I have configured it only for executable files, and for each of categories, AppLocker can do two things for us. The first one is enforce rules, which is the obvious one. So if something does not match a rule, it is not allowed to run, period, and over. And the second one is audit mode. Audit mode means it allows to run absolutely everything, but there is an entry within event log telling us it would be denied if we play seriously, which is great for polishing your rules before you start enforcing them, because it's one of the main pains within the whitelisting solution, how to do not break, how to do not interrupt your production, your system, your line of business applications with rules being too strict. So you can create rules, switch everything to audit mode, and then observe your logs if something would be blocked, and if yes, it is your decision, should I add it to my rules, or good to know, I would block it anyway. Here I'm using audit only to do not block anything. At the same time, I have everything logged within the log. As I said, AppLocker is using its logs. So here you have it, logs for those particular entries, and I have created a small view providing me a set of last entries here. So some automatic things happening on my VM all the time are reflected over here. So I can observe here, you can see some warning, probably something would be blocked, and this host from this path would be blocked. For a reason, it is not, it is running from my profile and not from program files or Windows. So it is not included within my rules containing only program file and Windows right now. Okay, so I will launch, I will create a rule for an executable file I have created. I have it on the desktop, CLS. I created a small application writing 100A letters. You will see in a moment why. So this is what my application is doing. Not a big deal, not very complex. I launch it from the desktop, so obviously if I refresh my log, I will see was allowed to run, but it would be blocked if we play seriously. Obviously there is no rule for this particular file as the path does not match any of those having configured here. What I will do right now, I will configure new rule for this particular executable file, and this rule, something is hiding over my taskbar, so I will do maybe like this. Next, it is for you to make characters bigger. Allow everyone file hash. Next, I will browse for files. I will specify on the desktop there is write AAA, open, create, and new rule appears over here. Right now, if I go for the same executable file, if I launch it again, I will see in my event log F5, there is an information, this particular executable file was allowed to run, which is perfectly well following our ideas and how it should work in, at least in my opinion. Okay, what I will do right now, I will go for a drive management. I will go with this again. I will go for the drive management. I will attach a VHDX file. Dear temp, you can see there is XVHDX file, and I will attach this file. This will simulate the thing I could do having two laptops, like plugging USB drive, removing it, plug it to other laptop, manipulate it somehow, and plugging it back. It is what I will do with VHDX file. So, attach VHDX, C temp X VHDX. Okay, new drive appeared here. It is the drive called X, and I will copy the file, copyright AAA, into the X drive. If I run it from the X drive, will it be allowed to run? It should be F5. X write AAA was allowed to run because it hash matches our rule. So, what I will do right now, I will unplug my drive offline, or detach VHD, even better. Okay, and I will manipulate it on the lower level from the different machine in a real world scenario. Here I will edit it with binary editor. So I will open my file, Control F. This is the string. It is why my application writes these strings, to make it easy to find on the image. So this is the string being written, and I will replace a bunch of my A letters with the X letter. So right now I will save the VHDX file, manipulating the content of the binary file. It is probably what all of us did in the primary school, trying to hack some application to display main name instead of the legitimate name of the author. I did exactly the same with the application I have created. So again, attach VHD, ctemp x VHDX, and I will run exactly the same x write IAA drive. And not a big surprise, I can observe a couple of letters within the executable file were changed. But the question is what AppLocker thinks about this. And you can see it is right now, 449, it was allowed to run. And the question is why? How it could happen that we create a hash-based rule. So if anyone changes any single bit within this executable file, it will be not allowed to run. I have changed a couple of letters, so it is definitely different, and it is allowed to run because of speed and because AppLocker wants to have it running faster because some data is being hashed instead of calculated every single time from scratch. So how I can verify this? I will go for this console. When it comes to hashes, PowerShell is the best one. PowerShell get file hash, write IAA from desktop. This is the hash. Get file hash x write IAA. This is the one from the X drive. It is significantly different. This is the role of the hash to visualize this difference pretty clearly. And of course, the file is different, but the cache remained the same. And the question is, where is the cache and how it looks like within the AppLocker? So if we are within the PowerShell, get AppLocker policy minus local, and I will send it to XML and to XML. And the policy for AppLocker is allowing me to file hash SHA-256, and you can see the hash starting from 6E38AF, which is none of those. What happens here? Actually, AppLocker lies, because even if it says SHA-256, this hash is not SHA-256 at all. It is AppLocker hash, and Microsoft nowhere documents how it is calculated. There is one thing here, because Microsoft does not document how the hash is calculated, but in the totally different areas of Microsoft documentation, Microsoft explains us so-called authenticate hash, used for digitally signed executable files. There is a special algorithm hashing only special part of the executable files to make it faster. And those hashes match. So we can guess it is authenticate hash, even if Microsoft does not really say so. So we have a pretty nice thing. By the way, I discovered it when I tried to pre-calculate hashes of like 100 of files and then drop into them to those pre-calculated hashes into the AppLocker, and none of those hashes worked. Why? I freshly calculated them, verified, and it works, and then I tried to do this by importing a file through AppLocker wizard, and I realized this hash is totally different. Anyway, this is how the hash is being calculated in practice. It is using AppLocker authenticate hash. If you really want to use SHA-256, it is yet another totally undocumented thing. I do not recommend rely on it. Instead of SHA-256, you can specify an algorithm SHA-256 flat. Documented nowhere, But if you use it, then real SHA-256 can be used, and it will work. Okay. By the way, if I have this command handy, I will out file. I will save it to a file, xml.txt. Okay, so I have this file handy just for the future. Okay, let's move 2 steps back. I have changed the content of the file, and it still runs because AppLocker believes it is the original one. So at the first run, before I detach the drive, hash was somehow cached, and after the manipulation, no one realized the content changed and the hash remained the original, and the AppLocker relies on the hash, on the cache. I will mess them talking to you too quickly. Okay, anyway, how we can display or play with those hashes. CLS, we can, after some digging, I have realized that the cache of hashes is being stored within NTFS extended attributes. If you know the idea of alternate data stream, this one will be very similar. Extended attribute is like alternate data stream on steroids. FSUtil file, there is a query AA command within built-in FSUtil utility. FSUtil file query AA, query extended attribute, let's say for the write AA from the desktop, and you can see some data. Here you have the information. We have 2 extended attributes. This is name of the first one and its content. This is the name of the second one, and the content is slightly bigger. And those are identified by AID1 and AID3. Here we have a thing. This one is documented because the name starts with $kernel.purge. What does it mean in practice? If an extended attribute name starts with the $kernel, it is allowed to be created only by the Windows kernel. This is kind of the protection. As I said, this one is documented. So I cannot create such attribute. There is no easy way of manipulating the attribute, but I can read the attribute, delete the old one, and recreate a new one if I want to play with them. Anyway, I cannot manipulate the $kernel attributes because I can delete them, I can manipulate them, I can read them, but I cannot recreate a new one, so it will simply not work. The second part of the name, .purge, is even more interesting, and it is again documented. If $purge is present within extended attribute name, the NTFS.sys driver within the kernel must remove this attribute totally if any change within the file content happens. So if I open my executable file directly from the file system with binary editor, if I change it, those extended attributes disappear because the content is changed and they disappear. If I reach under the NTFS driver, which I did by detaching the drive and the manipulating content, no one was informed, please invalidate the cache. So here you can see 6E38AF and so on as a content of the cache. By the way, it is exactly the hash being present within the AppLocker rule, even if you do not remember it. I have it in the text file. You can rewind the recording if you want. If I do the same for the X drive, X /, the content is exactly the same here, 6838 and so on. The cached value is the same. And AppLocker relies on this cached value. By the way, there is one interesting thing, because it would be good to know if a file is allowed to run or not really. Within the PowerShell, we have a test AppLocker policy commandlet. One of the parameters is XML policy. Another one is a path for the file. Here, I do not have to use path directly. XML policy. I saved the policy on the drive, so it was xml.txt, and the path, I have to specify the file to be tested if it is allowed to run. If I specify write AAA, I will see an information. There is a rule named write AAA, which makes the file allowed to be run. If I do the same within the PowerShell testing, how AppLocker will evaluate the X drive, you will see it will be denied. Yet another AppLocker beauty. Because AppLocker itself, the engine of the AppLocker, relies on the cache. And the test AppLocker policy tool relies on the real content of the file. Why do not make it this way? It is, well, you know Microsoft very well, I believe. Okay, so test AppLocker policy doesn't have to tell you truth because cache may tell something different, and the test commandlet does not rely on the cache, and the kernel driver relies on the cache. And another thing, because what did we did over here? We manipulated the content of the binary file under the NTFS driver, which has some potential, obviously, when it comes to malicious action. But it's not that great thing because you cannot plant your malicious file on the removable drive and then create the cache. So I will go this path. I will copy, maybe not from PowerShell, exit. I will return to my regular unprivileged console, CLS. I will hide this one because now it starts to be quite messy. Copy. I have a special application which is obviously not whitelisted for owning the system into the X drive, and I will detach the X drive. Let's detach it. I will display my rules by opening the XML.txt file. This is the file I have created a moment ago. Format word wrap. Here you can see the hash, and within the file I have, again, Control-C. I detached the drive. It was too fast because now I cannot plant the hash. Attach VHD C temp X VHDX. Okay, it is attached. So right now, dear X, I have this file. Obviously, this file has absolutely no extended attributes, which I quickly prove. FSU till file query AA X PWN, and it has no extended attributes because it was not launched so far, so cached hashes were not calculated, stored, and so on. It will happen at the first use. And right now I will plant a cache over it. So there is a tool, I'm sharing it on my GitHub, and it is on my desktop. So it is set AppLocker hash cache. You have to specify file name and the hash. So it is X PWN and a hash within my clipboard all the time. Again, can I create $kernel? Not at all. It is not allowed for me, but I can create an extended attribute called hash kernel, which is allowed because why not? So right now I will do the same magic, but on different level, and I will open a binary editor. My binary editor is still here. Reopen XVHDX, Control R, like for replace, $kernel port. Let's use uppercase again, not dollar but hash. $kernel, like this. Replace all. It happened. So right now it is named according to AppLocker expectation. if I attach my VHDX drive again, attach VHD, C temp x VHDX, it reappeared. Right now, if I display extended attributes here, you can see there is a perfectly legit extended attribute. So xpwn will launch, and when I look into the log, not a big surprise, it was allowed to run as the engine of the AppLocker relied on the cache I have planted within the previous steps. Is it dangerous in practice? When it comes to manipulating, attaching, detaching files, not that much. There is one trick. Attaching and detaching files, virtual drives, requires privileges allowing you to be an admin anyway. But when it comes to the physical drive being plugged and unplugged, yes, it may be dangerous. In practice, we are not meeting typical hash-based rules so often, but it may happen, and we can just read the rule set and then plant the hash information and then manipulate the content. But it works exactly the same way for digital signatures. Because if you remember the previous output, here for the PWN, this is the entry I have planted. For the write IAA, we have slightly more, like this. This is with AID3 identifier, also for AppID. AID3 and the signer info gives us a hint. If the file is digitally signed, the information about the signer is cached exactly the same way. So very common rule we have in our AppLocker deployments. Let's allow everything if it's from Microsoft. Again, if you are able to plant such NTFS extended attribute on a non-Microsoft file, it will be allowed to run because AppLocker allows us to run everything being signed by Microsoft, and reading it from the extended attributes, couple of bytes or couple of hundreds of bytes, is way faster than reading the full content of the file, hashing it, comparing it to the, verifying its certificate that is signing, if sign matches, verifying if the certificate is not expired, and so on and so on. Every single launching of application would be time consuming. Right now it is about reading its own cache and relying on own cache, not really believing it is possible to manipulate it. By the way, I will not show you, you can try it on your own. If you are using WDAC, WDAC has such cache, hashes cached quite similar way. There is one big difference when it comes to WDAC. The first one, within the WDAC policy, we can specify one very special value: please invalidate all extended attributes at reboot. So all caches will be wiped when your computer restarts. Another improvement within the WDAC is cached hashes are used only from the system drive and not from the removable drive. So we cannot attack removable drive for WDAC using this way, but at the same time we can use it for AppLocker. Yet again, thing to consider when you try to pick your solution to be used within your environment, because sometimes it may be a risk worth considering. So, to make it faster, Microsoft decided to cache some valuable data, and every single time we have a cache involved somewhere into the process, there is a possibility of doing two things: to change things without updating cache, or to plant a cache entry, to falsify a cached entry for some thing, and we can try to manipulate AppLocker this way. I will return to my slide desk. It is very complex slide desk, as you can see, like literally 2 slides, Shift F5, like this. Here you can see a couple of links. The first 2 are guiding you to the to my GitHub, where I publish executable files and source code I write in C mainly for tools I have presented. I'm providing a short write-up. This is the third link. And I also trying to demonstrate the full path, at least partially. It is less complex than today's session, but still you can follow the idea reaching the quick video I'm referring. This QR code is actually guiding you to 4 lines HTML page containing those links if you prefer this way. So that's basically it. Thank you very much, and hopefully see you soon again.
Do we have any questions for Greg after his presentation? Okay, you see the information, if you need more, is there. Sorry, just a moment, I'll bring you the mic.
I will try to repeat the question, but first I have to hear it. Probably someone from upstairs and going downstairs right now.
Sorry.
Anyway, I'm not running away, so
if you're upstairs, just please shout.
It would be great to hear the question anyway and answer if I know the answer. Anyway, I'm not running. If you go to my GitHub, you will find kind of a way of contacting me. Feel free to ask me to reach me. I can see one hands up on the left side of the room.
A real person, not just a voice.
You mentioned that mounting VHDX files requires elevated privileges. What about the ISO files? Because ISO files can be opened by users.
Yep, but ISO files cannot have NTFS file system. Those are CDFS, and CDFS does not have extended attributes, so it does not affect ISO files.
Okay, thank you.
Anybody else? Is this a person from upstairs? No. Anybody else with a question? No. In which case,
thank
Greg,
you again.
Again, thank you very much.